Hi everyone. Today I have Pradeep Sharma and Nitish Srivastav with me, and with them we'll spend time in looking into what is happening in the AI world, especially last 6 months, what's going on, and also some of the innovation they are working on and their team are working on. So my first question is that Goldman Sachs recently declared that the AI contributions to the US economy in 2025 was almost zero, right? The METR studies found developers were actually 19% slower with the AI tools, while they believe that they are productive. Most of the AI companies are claiming that the productivity is 10x or more. So, what actually is going on here?
It's a good time actually to be in the industry because you see messages coming from two different sides countering each other. On one side, almost everyone is convinced that the AI and AI-led platforms are going to give you the desired result. Actually, it is giving acceleration to the work that we do. And on the other side, there are people who take it to production are not seeing the desired result, right? And it is a true story from both perspective. And I'll give you a rationale. When we first saw a platform, I think you saw the evolution of Copilot on how it got evolved. But then Cursor and the style of iterative coding basically revolutionized the way people were doing coding. And I think when we as a manager, when we as a leader, when we tried that out, we believed that it should be able to accelerate 70-80% of my work because I see that type of thing. But the catch here is most of the work that we were trying on, they are a very unit work in nature. I'm trying to create a standalone application, and yes, it does a fairly decent job. With Anthropic and other models, you see it producing a work that is very hard for a small team to deliver in a quick time. So most of the companies have seen that actually, and they make it as a broader realization that, well, this is going to make my life easier. It is going to give me results that can accelerate the overall release cycle. So when you do a unit work, you get a sense like that. But then you see the other side, and the moment you take it to production, code is not written by one developer, and it is not just code. A requirement going through business analyst looking at how they should be done in a way that it has the business sense, a user requirement is getting fulfilled, to the way it gets converged into the overall architecture. Most of the things exist today. You have to augment your current structure. You're not writing a greenfield code. You take that forward to your implementation, testing, deployment, and then you hit the lag. You realize that while my coding is accelerated, or at least I get a sense that it is accelerated, I am not doing anything on my left and on my right side. And this is why was some of the most fascinating conversation we had are when we talk to the leaders and they say that, yes, I have used all platforms, but my productivity, when you look at from ideation all the way to release, is less than 5% today. It is predominantly because the tools are designed to solve one developer problem. And I think your secondary sentence also points another big gap where while you write code, the cost of rewriting it to make it fit into your overall architecture is a lot actually. So the net gain is very marginal. And unless we solve it in a holistic way, I think this problem will continue to happen.
Most AI developer tools live inside a single ID. Take example Copilot, Cursor, Cloud Code, right? I think they assume that a developer at one desk can actually build an enterprise grade application. But in reality, enterprise is like distributed teams, client server, database environment, 50 or plus microservices, architecture reviews, compliance, and so on, right? So how do you see that how much work actually one person you with all these tools can actually accomplish?
So we have seen in market research that if you are only focusing on coding, maybe you can achieve 15 to 20% productivity. And then even if you assume that there is just one single person doing everything, but it's just the coding, the developer is only doing the coding, then we have so many other things like integration testing, deployment, etc., which also needs to be enforced properly with the use of AI for productivity. And then, as we know, that it's not just one developer. A product is something that is built by multiple components. Each component is actually built by multiple team members in a team. So how would they all collaborate together for a common cause is something that we need to solve.
Now, some of the controlled experiments show that 30 to 55% speed up on isolated coding tasks. But if you look at the organization delivery metrics like lead time or defect rates or deployment frequency, that almost remain flat. So AI generated code is creating like 40 plus higher code churn and almost 7% decreased delivery stability. So are we just moving the problem faster or actually AI is adding value here?
So AI is definitely adding value. When the AI systems are they are bringing multiple agents, they look at your current code, they are trying to bring multiple dimensions and give you the required acceleration. They create lots of code and they will only get better from here. We don't think the models are going to stop here. The context, we knew a year ago that context is going to grow much bigger. Now I can send many modules in my single prompt to get my AI do something better. But again, as Pradeep was talking about, the challenge is not just about one developer looking at one part of a code. It has lineage with so many different components. Today, most of the tools are designed to sit at one individual's perspective. They look at one part of the code and it is creating a lot of acceleration there. In fact, to our surprise, we have seen how the need for having better program management has risen with the evolution of AI, right? So yes, you are right that the problem has moved from an individual developer's ability to write code to now having a better collaboration where all of these engineering motions that are out there, front end, back end, your database, your data exchange layer, all of them will have to go simultaneously. So your program management, the way you coordinate your architecture principle, they become even more meaningful today. And because you see someone running so very fast, it's like a football game, right? If one guy is running too fast, then others will have to run similar pace to get you to the desired result. Otherwise, right now, we see that developers are able to do something faster, but because they do not have, a similar acceleration on other sides, integrations fail today. You start breaking systems, and that's where I think you just talked about the code that you create. You now end up wasting more time on making it sort of compatible with the rest of the module. So you are true, you are right that we are now seeing a different types of problem coming, and just having an IDE or a developer disk acceleration alone is not sufficient. And we have been talking about it for quite some time. I think it is more evident right now.
Last month, Anthropic published a blog post and they claim that Claude Code can actually rapidly modernize COBOL code bases. Now that had a huge impact on IBM stock. It stock crashed by 13% and which was worst since 2000, and it wiped out almost $40 billion, right? I think in return, IBM SVP Rob actually fired back. He mentioned that the translation does not capture any of the complexity which was involved with the code, and he also mentioned that the modernization challenge is not a COBOL language problem. So now the question is, who is right, right? And what is your opinion about some of these AI companies making this claim but not backing it up? So what is your reaction to this?
Yeah, I mean, Anthropic was right that their models are able to write COBOL, the translation basically from COBOL to any modern language. It was not a wrong statement. Just that, if you take a small piece of code and you translate it to something new, that job is good. It is well done, but the extent of COBOL adoption is not there. It is connected to a much complex systems as what he talked about. When you saw the blog coming from IBM, they talked about the complexity. So Anthropic can solve a simple language translation, but you look at how that language was used to create a banking system which has so much of interdependencies with each other. I do not think that it is easy for any model to even get there. And I'll also give you something that we have experienced firsthand. In most of the work like migration, when you take a very large complex code with so many multiple modules like COBOL are generally used at a lot of BFSI segment, you look at the complex code, and when you are trying to do a migration even from a modern language to a newer language, you see hallucination at its best. It creates wrapper classes. Models are designed to show you that it has completed everything, right? So you get a sense that you have done the whole migration, but in reality, you have only covered a 30 or 40% of that. So yeah, I mean, the language translation is doable with new models. It is better when you have agentic system coming in. They struggle big time when you look at how complex the real world problems are. So can I use an Anthropic agent and translate a whole banking system? Absolutely not. And what is the extent we have seen success? Less than 20% actually. You end up spending a lot of time on completing those incomplete interfaces and implementation. So I think it was, again, every company, when they produce data set, it is only that data set, how much of that can be trusted. Sometimes they are right. Many a times these are overstatements. I think in this particular case, they underestimated the complexity a COBOL system brings to the table. It is not easy, by the way, and COBOL is not one language. If you see the real world implementation, there are so many variants comes out for a typical COBOL deployment. I don't think agents are smart enough today to solve it even to a 50-60% of accuracy. At some stage they will be, but that day is not today.
And also, just to extend what Nitish said, see, COBOL or any other programming language, it is only a means to create a purpose-built, complex platform for a specific purpose. Through decades of hardening, and that's exactly happened in case of the example that you mentioned, what Rob said, like in this specific case, it was, I think, IBM Z platform, and the software is purpose built for that platform. There are lots of nuances that has been baked into that to bring it to the shape it is today. So of course, if you are just looking at language translation, it's not going to make it.
Sometime back, Amazon's own AI coding agent, Kiro, autonomously decided to delete and create the environment during a routine fix, and which caused almost 13 hours of OS outage. I think sometime back there was all hands to address that all the Gen AI assisted changes and what some of the trends which is causing some of these incidents. Now they have mandated that there should be a senior level review and checks and balances are put in place in terms of how people are using AI coding. Now question is that if the world's largest cloud provider can't trust its own AI agent, then why should any enterprise? How do you think about this?
I mean, the specific incidents that you talked about is a very common phenomena. I mean, one of the best agentic system that came so far is OpenClaw, CloudBot, lots of name to that system. Amazing actually. But then they have access to your file system. They have access, full access, like an admin access given to your agents. And this is where even the best models that are out there, your models can only give you indication. Your agents will take those things and will, in an autonomous way, take their own decisions and do those changes, right? I think it was inevitable that if agents have power, if agents are designed to do changes, actually, looking at one dimension of responses coming from a model is right in saying that why don't you delete an old system and create a new system. It underestimated the complexity. It underestimated how it has integrations with so many other pieces. So it is bound to happen today. Agents, this is why agent adoption is very limited today, because the systems underestimate the complexity of integrations, the lineage, data flow, permissions, security, guardrails. I think at some stage industry has either realized or they are slowly realizing that Having agent alone is not going to solve a problem. You need different guardrails. The same way that when humans were doing the job, if you recall, in very past days, when you make a code change can potentially break a lot of things. That's where the review processes were set in place. So I think it is a learning phase for industry. They are slowly evolving. They are realizing the power of agents. Various guardrails are needed. But more than that, the organization context about why certain things were done is extremely crucial for them to replicate and then automate or orchestrate using agent at this point.
Yeah, maybe a couple of more points. So what we have seen as a pattern that once AI decides to go on a wrong path, then it keeps building on top of it. And we have seen that pattern a lot of time. And then if you have AI to write something and then AI to review that, I mean, you are set to fail anyway. So what we really need is that lots of deterministic toolkit, scripts, etc., which you might have created using AI itself, but it was done in the design time by experts, hardened at that time. And now at the runtime, you have all those deterministic toolkit at play to reduce these issues.
Now, as AI is evolving and platforms are becoming better, there is a growing narrative that long-running autonomous agents will plan, code, test, and ship. Now, foundation model companies are making bold claims, but the enterprise software has architects who decide what's the right thing. They have domain experts. They have other specialists who actually take a decision on how they want to build the software. Now, this superhuman agent kind of approach, single superhuman agent kind of approach, do you think it is fundamentally broken, or just connecting tools and MCPs will create the magic? So how do you see this coming together?
So actually, the way we are currently looking at this problem is completely wrong. Uh, how we used to do it before AI arrived, we have to mimic that kind of situation. Only then we can solve the complex problem of real world. So that I see as a very big gap in the industry right now. So we have to look at it in a very different way, in a collaborative manner. Each phase AI is available, they know about each other. There is a governing, AI toolkit and rules at a higher level, which are looking at every phase. So only then I think this problem can be solved.
And just to add on that one, the approach of one single agent, super agent, or a collection of agents coming to solve a problem, when you are creating a simple system that crawl my internet, get news, try to summarize all of it, make a meaning, create a blog post for me, I think for these type of use cases, that's just an example, a simple workflow is easy to sort of replicate with a few agents. A distributed system, as Pradeep talked about, a system where you have client server architecture, a system where multiple personas sort of collaborate together, it's very hard for agents to replicate it completely. And that is where the collaborative framework is needed, and I think industry, while it has solved agents, I think it is on the path. They have not really gone there. And this is one of the reason AI adoption is limited.
And we have seen for complex problems in many cases that it's not able to deterministically even plan. Every time it creates a different plan. It has a different understanding of the problem. So, and this problem is not going to be solved just by having a bigger model or a larger context. It has to be thought about differently.
And that's a good segue to my next question, because if you look at the enterprise knowledge, like it's distributed, right? Code, documentation, tribal decisions, tribal knowledge which was sitting with people who have retired, no longer there in the system. Now, see, if you look at security, it's just not about scanning. If you look at architecture, it's not about just diagram generation. And if you look at governance, it's just not checkbox. So none of this lives in IDE alone, right? It is a lot of things which are outside. So what it will take to solve this enterprise level AI approach or problem?
So I think industry learnt it hard way. The evolution of MCP gave us a way to connect all of the systems that you talked about together. But again, they are not simple sources. I'll give an example. If I am trying to create a sales agent and it is connecting to a document repository where I have 5 different versions of the same statement of work, your backend system, which is your enterprise knowledge or context, will have to understand all that. How many systems are there today which can resolve it? It is very limited. At the same time, as we look at other things, you talk about ticket, the lineage of any information, a ticket leading to product manager trying to create a feature getting into your tool, coming to a developer desk for implementation, the ontology of all of this data, they becomes crucial actually at this point of time. And when you look at organization context alone, that is the biggest problem that is blocking AI adoption. So a developer desk assume that this context is there, and it is there for a developer. A developer looks at a piece of code. He is required to make a code change. He can do that code change. But as they look at a larger story that my code change is impacting a client which is talking to a server, can break a protocol, do I have that information there? It is limited. So I think your point about, well, architecture is far beyond a diagram, because a code is not just one developer code, it's a very large repository. There are multiple modules, integrations, and then external integration. Most of these systems expose APIs that third-party systems are using today. So the system that we need today is something that brings organization knowledge together. I want to also add, and then I think Pradeep, you should definitely talk about it. I think you look at companies like Glean, you look at companies like Google, their Vertex, Amazon Q were trying to solve it in a way. So they were trying to create this organization knowledge, which is essential for all of the agents to use and then to interact. They lack analytics today, so while they can store data, let's say I'm trying to create a system where I'm looking at last 1 year of record. Are they smart enough to understand all that? Actually, that is a limitation today that they will have to overcome. So yeah, I think it is not one developer. It is not a context within my ID. It is far bigger. In nature, you connect all your systems, have a system that does everything together, and then take a decision on that.
And plus, other thing that I would like to talk here is that even before AI came, all these different personas, they have different interfaces, right? So why should we force fit all of that, that now there is a chat for everybody? So that is the wrong way of doing things, right? So we have to preserve that, and AI should be augmented. At the same time, all these different systems should be able to seamlessly cooperate with each other. We need a solution like that.
Thanks. Thanks. Actually, it has helped us to understand what is happening in the industry and how some of these changes, and also you talked about a lot of these challenges in solving an enterprise grade problem. You, Pradeep, you just mentioned about this, and that's my next question. That today, if we look at most of these AI tools, they use single interface, right? And there's one single interface for all the personas, as Pradeep you mentioned. And I think you are trying to solve this problem in a very unique way. What I know, and I want to hear more from you, is that you have a role in mind, and then the interface and the experience is very unique for all these roles, from product management to business analyst to quality to developer. But I think the foundation brain is same. So talk a little more about, first of all, about your reasoning for that kind of design decision and how it is going to help in your enterprise problem solving.
So if you are trying to solve a problem, let's say you are trying to create a software and it has multiple components. So then for each of those components, you have a team who is building it. But then again, this is only one side of the story. Then there is a team for integration testing. There is a team for deployment. There is a team for product managers and so on, right? Overall, together, collaboratively, they are trying to solve one single problem, right? That's together they are working towards that. So if we are trying to solve this problem, somehow we need distributed workflow or a distributed brain which somehow understands all these pieces. It is created at a high level in the beginning, and as it goes through various stages to various teams generating code to various other personas, each of those teams have those portions of workflow already defined in the beginning, but now they can further enhance it according to their own expertise and then execute it. At the same time, there are guardrails which are already defined when the problem was defined, and somehow these are all collaborating with each other. We know the dependencies, so that this whole system works towards a common solution.
If I try to simplify that one, there is organization knowledge, we call it the organization context. And then for a particular problem, you design a brain where you say that I have to get a product manager using an interface which is intuitive for a product manager to bring market perspective, to bring customers requirement, to bring anything which is from a business perspective, look at all of it, create requirements in a way that it brings different players like a developer, tester as part of a larger plan. And what Pradeep always talked about, that when you look at a traditional way of solving a problem, you have architects, they put their brain, they create a master plan, and now they bring people to come and collaborate and work on it. But they will not be using an IDE interface or a browser alone. A product manager has confidence, or they are used to a browser world where they are sort of working in a model. Sometimes they use collaborative platforms like SharePoint. A developer uses IDE, sometimes they use other medium like Slack, etc. A testing team have their own interfaces. So the knowledge, the brain, context, all will have to get expanded in all of these different medium to provide the required interface.
So you have introduced a new term which is brain, and it sounds like it is not a prompt, it's not a chat, it sounds like it's a workflow and then architect is creating it. So can you elaborate more on a little bit why brain was critical to have something like that, and also how do you see helping in the overall improvement of the output?
So if you see, like you discussed in the beginning, right, that we are only seeing productivity of 10-20% overall, and even that productivity is only not for very complex problems. We have seen time and again that if we are dealing with a very complex problem, AI hallucinates every time there are new results. For example, if it's a large code, I'm just trying to find out, convert something from monolith to microservices. I'm just trying to find out bounded context so that I can see that what microservices I should come up with. Every single time, because it's such a large code base, it comes up with a different result. So now if you see, if you have read Peter Thiel's book 0 to N, it's like a 0 to N moment for the industry. So 1 to N is where you are just doing what you were doing earlier. So you will only raise the bar that much. But now you have to look at something completely differently. So that is what I think is required, where you have to see that if you have to come out of this problem, that we can only increase productivity to this extent. And if there are so many different components, how do we actually solve the problem so that we are not using AI as an independent tool where developers are increasing their productivity, then maybe product managers are increasing their productivity. If we look at the problem as a whole, and if it operates at one level higher, and somehow we have a higher plan which is getting distributed across these stages, that is when we have the true value of AI will be unlocked.
So if you look how the things are happening today with this kind of AI model, so you have a front-end developer working on the client side and the back-end developer working on services. Both have different environment. The brain is doing the orchestration, bringing all the sequences, dependencies together. So how exactly this multi-participant, multi-environment complexity is actually getting handled through brain?
Try to step back what Pradeep talked about. A few years ago, as the evolution of low code, no code, systems, when you look at the RPAs, the business process automation systems, they created deterministic workflows, right? Where they say that there is an input, there are set of processes. Under each processes, you have input, process, output. You bring all of them together to solve a problem, right? They evolved from there. They brought in the concept of dynamic code in between, that at every stage you can have systems that can call a third party system. It became very effective. That's how most of the process automation worked. Now you see it as one unit task, right? If my AI can generate one unit like that, and then I have many units coming together. So if I look at a problem, I have many such RPAs, or DAGs created that is, clubbed together in a flow basically. And the AI is taking a decision that under certain scenarios, I am calling A, B, C. And if some changes happen, then I go D or I go back to C. The brain works like that. A brain is nothing but set of deterministic workflow that is created with the help of AI, and you stitch all of them together. It has places for people, the personas you talked about, developer, tester, product managers. It has places for systems. I have system A, which is supporting my build related activities. I have a system B where my gateway gets deployed, let's say. I have system C where I'm running a client application and I have to bring all of them together to validate a step, right? So on one side, I have personas, on other side, I have their systems. And similarly, I may have resources. Like for a system A, I have a resource that builds a code. For a system B, I have a resource that makes a call to your ticketing system, try to pull out something. And then under certain scenario, you bring in these personas, their resources, their systems to come and solve one part of your problem. And then that is how you solve the whole problem. So take an example. I have a requirement of updating my gateway to support a single sign-on. I have a user interface, I have a backend system, I have an appliance that is out there. I have a developer creating a change for front end. I have a developer doing a back end. Maybe they are same developer, maybe they are different. And then I take it to a production like setup. I build, run, and then validate. A testing persona comes in. The brain orchestrates all that, ensuring that the right workflow is maintained, it is following the right sequence, and all the stages are complete. If it hits a problem, it gets back to the older stage, repeat that process till it hits the cycle. So in the concept of a brain brings all of the dimensions together. It is creating a very well-defined structure of how they will be working, what are they required to solve, and once they get the desired result, it get to the next stage where new players are coming in, new resources are coming in to solve a problem. So what a cursor or Windsurf was doing at a unit level, you see it at a mesh of all that coming together, and there is a controller controlling all that together.
So let's make it concrete here. So, and going back to the same example of COBOL modernization, where Anthropic claimed that a coding agent can handle it, and IBM leader said that no, for doing this you actually need a lot of things on which the application runs on. So in this concept of brain, how actually it works and how it brings together so that the 95% of the part which is missed in typical normal coding is addressed.
Yeah, so if you go back to your earlier question, so what we discussed is that this is not just COBOL translation, right? It's a system purpose built which we are trying to migrate, which has lots of non-functional requirements. I think that is one of the key differentiation. How does it scale on? How does it run on a specific hardware and so on? So now, if we look at it, how do we solve this problem? How do we migrate it? So initially, what you have to do is when you are designing the brain, you have to look at all the participants. And like Nitish said, participants are systems. For example, IBM Z running something in hardware, specific hardware. Those are personas, different developers, architects. Somebody is expert on certain microservices, somebody is expert on certain components. So at a high level, we design this brain. And when we design this brain, we don't just use AI. That's one of the main key differentiation. So we use lots of deterministic methods to feed into the system to create this higher level brain. However, to create this higher level brain, we might have used AI, but that's used in the design time by experts and then hardened. There is a very big differentiation. And once you have created a brain, now it's being sent through all these systems and personas, and so they know their part. They know what is supposed to be done, what are the overall guardrails of the brain that they have to implement, what is required from them. And then they also have a leeway. They do their own planning. So for example, if there is an architect who says that design a module like that, but when it goes to a lead, there are multiple ways to do the same thing. So as long as it is enforcing whatever architect wanted, the lead is free to choose one of the methods that they think is right. So this is exactly the way it works, that different personas, different systems come into play, and together they make the overall outcome happen.
So you are kind of emphasizing the need for iteration, going back and forth and getting the best result. I think the reviewer is reviewing and giving the feedback, deployment surfaces an issue and the brain loops back. And I think in our Amazon example where that Kiro was not able to or generated the error, I think there the approach used was fire and forget, no iteration, no human judgment in the loop. So in this case, how important is this iteration process and how that is baked into your entire solution?
So when you look at distributed systems or when you look at complex system, iteration is very important because you take a step and you realize that the desired result is somewhat different than what you anticipated during your planning. So I'll give an example. When I create a plan, when our brain is looking at a complex problem, it created a high level plan. In the plan, we realize that when I am at step 5th, let's say, and we are trying to we are getting into step 6, I'm expecting my 5th step to give me some desired result. We are not getting that result. We are getting somewhat different result. I'll have to rebalance my whole plan, and then now my step 6 or maybe going back in step 4th will be decided. So it's a very complex way of sort of taking decisions because they are all knitted together. The result for one of them defines everything. And we have a very interesting concept I'll have Pradeep explain. We don't see them as a linear sort of linked list of all the steps together. We found a way where we say that they are all segmented in their own sort of swim lane. There are multiple stages there. We gave them all a name. And as we look at, you can move from one lane to another lane, and within a lane, you can move from one part to another. And it is very important for you to understand because this is one of our like deep innovation that we have done. We protected the innovation because we believe this is how complex systems can be done. So I'll let Pradeep explain how have we planned all that because this is very, very important and very unique way of solving the problem.
Yeah, so basically what we have been building is dynamic graph of agents. Based on the problem at hand, we decide at runtime that how this dynamic graph should be created. And the planning of this graph itself can be overseen by architect. They can give comments until they are satisfied. This is like a high level brain being created. And when the brain is executed, we divide this into multiple stages, which we call waves. And it decides that in each wave, how many phases are there. Maybe some phases can run in parallel. Some has to be sequential. What should wait for which one? Which phase should be running on which system, which hardware, which similarly by which persona. And all of these, they are collaborating with each other. They know about each other. They know about their dependencies. And they are sharing common context if required, the organizational context as well. And this is how we plan to achieve this overall approach.
So one thing, it seems like that this brain is a shareable brain, and an architect who figures out the best solution or best way to solve a problem for, say, for example, Spring Boot upgrade across 50 microservices can share this way to solve the problem with other teams, maybe other functions and maybe other organizations. So today, normally this knowledge is sitting with the architect, right? If they walk out of the door, then the entire playbook just goes with the person. Now with this situation, when there is a brain which is shareable, which is becoming powerful every day, how it changes the dynamics and the economics of software development?
Oh yeah, it is very, very important actually. Industry has seen how skills are powerful. A skill is a repeatable structure that AI generates and you can call it to do a job. When you know that something is definitely repeatable, you don't want AI to recreate a plan for you. see this brain as a much glorified mesh of skills. The way it is doing, and it's a very innovative way of again solving a problem, that it is not only multiple personas Pradeep talked about. It is personas, it is resources, your systems, they all come together. Now, as you look at this mesh and you see that I have created a mesh which is solving my migration, and the reason why we got there is also very interesting. Pradeep and we were trying to solve a migration problem. And none of the AI system, no matter how many running agents we kept, we never went past a 30-35% of migration, which is painful because AI generated a 35% code is as good as AI deleted your 30% of code, because your new team doesn't understand what it has created and it has not completed a job. So it was a complex problem. We were using some of the best frontier models, and I'm talking, as we are recording today, it's the model that came a couple of weeks ago. It's not solving the problem. So then you bring this brain, you stitch everything together, you realize that it is solving a migration problem. Now the way we have stitched our brains, these individual waves and phases can be taken up by another team which is solving a similar problem. So it's like I giving my brain to you. You can use a brain, you can customize it. If you are doing, let's say, a .NET Classic to .NET Core, a lot of my learning can be reused there. So the way you can create skill and share skill, our brain can be shared with other teams as well. The teams can decide how many of that needs to be overwritten. It's a very easy way of customizing a brain. But the whole rationale about a brain is at some stage for all themes, migration, modernization, when you look at upgrades, you have the standard brain created, people create their derivatives out from there, but the foundation is staying the same. It gives the required acceleration in complex tasks as well.
So let's talk about product management and the business analyst side, the most underserved areas in enterprise AI. Now, in your platform, product manager does not type just the requirements into a document, but they can bring in users, data from a lot of sources, stakeholders information, and then AI can synthesize the structure and feed the brain, right? And there is no loss in communication or no handoff loss. So this collaborative way of working and the workflow creation, and there's no risk of that we have built the wrong thing. How it is going to change the way these functions are actually taking the AI?
Yeah, I think we talked about it in past as well, that with organization context coming together, you create a brain out from there, and all personas are using it together. There is always a lineage between events. Product managers getting a ticket or looking at market research, trying to create a requirement. When he is creating a requirement, you understand that the requirement system understand your backend code, it understand your deployment techniques. So it is never going to create something which has to go through so many iterations before it hits a developer desk. Right there for the product manager, interfaces are created to solve this problem. So just by connecting the systems together, we are getting the desired acceleration, because there is no loss of information because the product manager doesn't understand how a deployment happens, and certain commitments are done where you have to go and then change a lot of systems. So personas are aware of the end system and then they are working on it.
So Nitish, now every AI company like Anthropic, OpenAI, Google, they are racing towards making the smartest single model, single agent, trying to solve the problem in that way. And you are going in a totally opposite direction. You are talking about multiple humans, multiple environments, multiple AI assisted workflows, and trying to solve it in a very collaborative way. So why do you think that this is the right architecture, and why no one else has actually tried this?
So it is not a right or wrong architecture actually. They are doing certain things because it is giving them results to a certain extent. But I think you started asking that the productivity is less than a 5%, and we have seen it ourselves as well. We all tried migrations. It didn't work. It didn't work. It didn't work with Anthropic latest model. The model is great, but you need a different approach. When we look at the end result, we realize that the collaborative way of solving it is the only way we have seen it producing the desired result. That actually is all result driven for us. Is that the only way to solve a problem? Absolutely not. I'm sure there will be more ways of doing it. And a lot of inspiration came through some of the recent innovations that we have seen out there, where you understand that the earlier problem of a shared context was a little difficult in the first wave of this AI journey. So for us, it is all about the outcome. We have taken a careful decision that relying on one agent, one persona is not going to solve the problem. So let us bring this collaborative thing. Our results are good. We are getting encouraged by the type of complex problem it is solving today. And that is why we think we will continue this path for some time unless you see evolution coming in frontier model themselves. Maybe they come up with something that can start getting you the desired result, all the problems we have seen. At this point, they do not have any solution like that. And again, when we look at how they solve a problem, we believe that it can take me to an extent beyond that. The last 20% of any work is done by a very customized approach, and this is that customized approach. And that's why we are seen different. It is not really different. I think it falls into the same agentic workflow that people have been talking about, but it is not one model that can solve a problem. You need multiple models. You need multiple personas, bring systems together, connect everything, and then you see the reflection of what is being done and change your approach to get the desired result.
So for the CTOs who are watching this discussion, most of them have actually made some choices on the AI platform or the agents or the workflows they are going. So is it for them, if they want to use this new approach of brain, is it like rip and replace, or there is some alternate way of getting the best of both the worlds?
I mean, we designed it in a way that it can sit on top of any system. Today, it works with our system. I'll let Pradeep also comment on that, but it is dynamic. The brain is dynamic. It can connect to underlying agentic infrastructure. Our vision is that at some stage, even the business agents that you are creating to solve, let's say a document processing, or you're doing something which is a business automation, the brain can still solve that type of problem as well. We designed it in that way.
Yeah, and we actually see it, whether these are harnesses like Cursor or even models, Anthropic, etc. These are actually for us, these are just execution means. So we can replace it, like Nitish said, and what we are working it at one level higher, that how we have to see this problem in a very different way, that there is a software, it has multiple repositories, multiple components. There is not one developer, taking all the repositories together and trying to solve everything together. That is where we saw a very huge gap in the industry. And when we were trying to do it in a traditional way, like others were doing, we were not getting the desired results. So we slowly started shifting in the direction that we have now implemented in SASVA.
So when you bring AI into the every phase of software development lifecycle, not just coding, now what kind of gains are actually achievable? And I'm not talking about like vanity measures like lines of code generated, but real business impacting measures for the complex work, like whether the quality has actually gone up, my time to market has gone down, those kind of things. So what is your take on this?
It is early to comment actually, because our experimentation and some of the live work that we have done, we have seen very good results when it comes to factory work like modernization, migration. We have seen migration reaching almost 90% with this, as compared to a 20 or 30% with the traditional approach. But then this is a place where once it go live now, we are doing a GTM pretty soon. We'll see how industry respond to this technique. But I think the results are very encouraging. And yes, it is all about the quality of work. If I'm doing migration, then I expect migration to be seamless. It should do the work that it is required to be done. And speed to market is another big aspect that people will be tracking. I think the productivity will be eventually measured with these two parameters. So yeah, that is the direction we are going, and I think results are good. Once people start using it, they all will understand if it is really giving them So our journey is not about a 5% or 10% of productivity. We believe AI can do much more.
Now let's talk about the classes of work this can unlock. Now in the industry, if you see, there is a lot of work around large scale migration, framework modernization, platform upgrades, and these are like complex, risky, and expensive propositions. So what do you think with this collaborative brain orchestrating the full life cycle? What kind of new work which can be unlocked, which was not possible earlier?
A lot of things you talked about. I think large scale transformation, migration, people were scared of taking up many assignments. They were done by people. We have seen, we took one example of a SAP migration to the H4. Like when you look at, again, any complex task that involves multiple systems, multiple personas will get unlocked with it. And the type of use cases we are going after, it starts with what I just talked about, a migration modernization, eventually to creating complex system as well. You look at industrial problem, you look at automotive problems, they're all distributed in nature, and you have zero room for any hallucination there. You can't have an agent making a Amazon type mistake in an automotive world, right? It has far bigger implications. So we believe that we can take AI to those sectors as well, and we'll gain big time with that.
So there is a fear that AI replaces developers. But whatever you have shared with me, it looks like that it is doing the opposite, because you are putting architects, product managers, developers, QA, reviewers in the center. Of course, they each one of them have their AI augmented workflow and new way of working. So what is your take on the future of engineering delivery models?
Yeah, so see, like we mentioned earlier, that when we are solving a complex problem, we are not thinking that one developer or one persona will sit on their interfaces and then achieve the job in few hours. We believe very strongly that it has to be a collaborative system where AI and various personas and various systems need to work together. And then there is also a concept of using AI at not just in the runtime, AI at the design time, as well as AI at the runtime, which when you are using AI at the design time, you are basically converting those many problem statements into deterministic toolkit, and then using, and this is done by experts. So then you reduce the risk of AI hallucinations.
And I want to just add that the roles will stay back. Today AI systems are designed by giving a prompt that think like an architect and do an architect job. The same AI system you said think like a developer and solve a developer problem. That's not a way it will be done. Our approach is, yes, you may need less number of engineers. You still need engineers to do the job. At this point, AI is far from being completely autonomous. What we are trying to solve is providing the required acceleration to each of the layer to be meaningful and to deliver results that can be accepted.
This is my final question. If you see last 2-3 years, the industry was chasing single developer productivity goals, and basically the gains are not in at par with what we were expecting. We have discussed about the impact on IBM, and also we discussed about the Amazon story. Now what you are saying is that your platform is actually putting collaboration, multi-role, multi-environment concept in the place. Now looking back, whatever we have discussed, if there is one thing which you want CTOs and senior architects who are watching this to take away from this, what will be that?
I think do not underestimate the complexity of any environment. Some of the environments are simple. Your vibe coding is suitable for that. Somewhat complex environment, you can still augment a lot of AI, you can still get the desired result. In an enterprise setup, the world is very different. The notion of you trying a simple application by doing a vibe coding and expecting your engineers to then go and solve a real world problem at the same speed is a bad, it's not real actually. Today system is not mature enough to give you that. I think there is a need to do expectation reset. We learned it hard way ourselves, but at the same time, you think the way you have solved your past problems. you know there were times when you bring architects to look at the overall requirement, design a system that can take you to the real production expectations, I think that is not going away. The second learning that we all have seen is AI is evolving every day. Models are coming, there are innovations that are giving you better results. Some of them are actually pulling you back. It's very easy to latch on something new, but then again, to test it in a real world environment is crucial for you to take a choice on technology.
Also, I would like to add that, before AI came into picture, when we used to do a complex problem, for example, a complex monolith to microservices migration, if it used to take, let's say, 6 months, 8 months, from there, we are not going to go to a world with that there is one developer sitting in a room, spends few hours, gives lots of prompts, and then finally you get an output which is now converted. It will never happen. It will happen for small problems. It will happen in a very small setup, but in a real world, it's never going to happen. But what will happen is that instead of 6 months, now you have, maybe you will be able to achieve it in 1 month or 3 weeks. And then there are still multiple personas collaborating together. They are using AI, some are using in the design time, and some using at the runtime to now achieve the desired results.
See, someday we will reach to a stage where AI will be able to do a lot of things. I think innovations are heading in right direction, but for a company to come and say that, the humanity is in crisis and, AI can write everything.
Not anytime soon.
I don't think that is the right expectation unless we recreate everything in a very simple prompt based technique. I think we are far from there. It is heading in right direction, but till then you still need, orchestration, you need design thinking to be at your core to get you the best possible results that are out there.
Thanks Nitish, thanks Pradeep. It's always very informative to talk to you. Thanks everybody for joining this session. Hope you found this very informative. Thank you.